that. All right, so we're going to jump into NATS as a service mesh. Like Ginger said, it's a hot topic. This topic came up for me personally, summer last year, late summer, early fall. With I have an open RMF tool. I have an open source tool that I'm using NATS behind the scenes. And I got to the point where some of the ideas around service mesh were making me ask, hey, do I need that? I was already using NATS for some eventual consistency work. And it basically was, I was wondering, okay, do I have enough inside of NATS where I can get what I need done? I don't necessarily like the complexity of service mesh. I've talked with a couple people on the Slack channel. So a question came up on NATS Slack. It's a great, if you're not a part of that, I would go get that now. There's a lot of good info on there. So a question came up. I had been writing notes for my own job and for my open source software on using NATS and around this idea of service functionality. So I had probably a page and a half of a Google Doc, some notes on that. Somebody asked the same question, kind of threw it out there. Ginger or Colin, somebody asked me to start putting that together. So I wrote a couple Medium articles that are out there. You can search for NATS service mesh and find them. I'm not going to bore you with the URL, but wanted to jump into basically. Let me jump in here. Wanted to get to the point of defining the service mesh, and then talk about some of the particular features at least I was interested in. Discovery, metrics, security tracing, load balancing, routing control, things of those nature. So as far as service mesh goes, to level set, to basically talk about what that is, that you can search on that and you can probably find 5 or 6 different definitions, I guess I would say. But what we're going to talk about here, it's the infrastructure layer for your application to work behind the scenes. It's usually involving microservices. Most of the examples you see use Kubernetes, even though they say they don't need Kubernetes. Most of the examples you see use Kubernetes. Discovery, distributed caching, load balancing, retry, timeout, circuit break. There's authentication, auth-in, authorization, access control list, all the stuff you see here. Automated rollouts, whether it's Canary or Blue-Green. Traffic shifting, mirroring. So personally, I had a lot of these questions going on with my own application, which made me kind of sit down and ride through what I'm going to show you. So let's jump in. So, why would you use a service mesh? That's really the next question. I had this question asked to me 2 days ago. Hey, do we need a service mesh? My answer would be, if you're asking that question, you probably don't need one. That's my answer. If you ask Colin Sullivan, he'll probably tell you why a service mesh is bad. I've had that conversation with him back and forth. So why did I need a service mesh? Mutual TLS, security in both directions. Trying to put the complexity of the retries, the calling, the service discovery, trying not to have every single one of my services have that in the code, put that in the framework. Also, ephemeral containers moving around in Kubernetes. You have things spinning up and down as you push stuff out, as you spin up your replicas, things of that nature. I'm using Kubernetes. Some of the other things that I see out there personally, you're using Ginger hinted on it. You use service mesh because there's a lot of hype around it. Because you read it on Twitter. I saw it at KubeCon. I was there in 2018. I wasn't there last year. In Seattle, there's a lot of talk about service mesh. So again, the one thing I wanted to stress, and I'm not going to dive too much on this. Make sure you need it, because there's a lot of complexity in a service mesh. Make sure you need it. Make sure you can implement however you need it. Whatever pieces. Make sure you and your team can support it. I would say that's pretty critical. Some friends of mine that are on this call will note that you better hope your team can support that kind of thing. So where are they used? You can do a search on this. Again, I'm not going to harp on this. You have Istio. Istio seems to be the one a lot of people are harping on. Aspen Mesh. There's Tetrate. There's Red Hat has a Red Hat OpenShift service mesh. Linkerd 2.0, actually, they rewrote part of Linkerd in Rust, going back to the gentleman about an hour ago, talking on Rust. Kong has Kuma. HashiCorp has Console service mesh. There's multiple people coming out with their own flavors of Kubernetes, their own flavors of wrapping that up, and their own service mesh. Users solve problems. Usually, they're used with larger, more complex systems. So again, this isn't a deep dive. It's 15, 20 minutes. We don't have a lot of time to go into this, but just wanted to at least level set on what we're talking about here. All right, so if we talk about the different pieces, we talked about service discovery, metrics, things of that nature. Service discovery. So I'm going to jump through some of these, explain basically what we have going on in the service mesh realm, as far as like Kubernetes, the Istio, things of that nature, and then what we have going on as far as inside of NATS, at least what I saw, and how I ended up answering my questions that I needed around this. So, service discovery here is basically, hey, where are you? You have multiple services; they need to know where each other are. That's probably the easiest way to say that. Call by IP, call by name. To the right, to my right, on the right, you see the service mesh diagram that's literally stolen from the Istio docs, Istio.io or whatever it's called. They're literally stolen from the Istio docs. There's the service A needs to talk to service B. Where are they? They self-register. They store in a registry, and that's I'm high level talking about this. They store in a registry, so they know where each other are. So in order for my service to know what this other service is, I need to call it by IP, by name, whatever the case may be. I need to keep track of where that is. So that's a service discovery mechanism. So how does that work in NATS? This was my first question that I had to answer for myself. Where is this inside of NATS? Hey, where are you? Multiple services calling each other. What I was really studying, one of my aha moments was, I don't necessarily need to know. I need to know that they're out there, but I don't necessarily need to know what service is running. I don't need to name the service. I need to know what subject. I need to know the topic or the subject that I'm publishing. I need to know what that is. I need to know if it's request reply. I need to know that there's the subscriber on the other end that knows what the topic is and can listen to it. In 2.0, you have NATS 2.0, you have the accounts and the consumers of services. You need to make sure all that's set up. I don't necessarily need to know where the thing is. I just need to know that it's going to work for me. So this horrible picture that I wrote to the right over here kind of talks to that. If I'm publishing app.person.save or person update or whatever, I need to know that I can publish it. I need to know that there's a subscription that can pull it down. I need to know that there's a save mechanism or a delete, or there's persistence, there's auditing, there's logging, whatever I'm building into my system. They need to know what topics, the topic hierarchy, that's really the more important piece here. So for what I needed, that was enough for me. That was enough. This is going to be, more along the lines of what I'm doing here. Security is another piece that goes into there's mutual TLS. The security piece goes into the service mesh idea as well. So when you think of the service mesh, I'm doing air quotes here if you can't see me, service mesh. What you're looking at, it's the end-to-end encryption, authentication, again, off-end of the access control. Most of the stuff is done in YAML files, good, bad, or otherwise. One of the things I talked to Colin Sullivan on from Sanadia, it has a centralized security model versus NATS, which we'll see in a minute, it doesn't. So the one good thing it does manage the security certificates for you. So that's kind of important. So security in the service mesh, it gives you that. I don't have to write all of this into my service, my Go service, my C#.NET Core service, my Java service. I don't need to do that. It's inside of the service mesh itself, end-to-end points. So how does that work in security as far as NATS goes? Well, if I was studying how NATS worked, this was around the time that 2.0 was coming out. It has some of the things I already mentioned: M keys, JSON web tokens, the operator account user security model. It's more decentralized, so there's something on the side that's actually setting it up, and then it sits in a separate server or memory. You can run TLS. You can run with your certificates. The caveat being for NATS, at least, again, what I talked to the community on inside the Slack channel I mentioned, was that you have to manage that. You have to make sure that you manage the certificates. So that there's a trade-off there. But you have to figure out, for you, for your team, for your application, what do you need and how you're going to fill it. So that's one of the things to keep in mind there as well. You have metrics. This is one of the things, the team that I'm outside of my open source piece, my quote unquote day job, we're looking at metrics and how to track metrics, how to track that, how to store that, things of that nature. As far as metrics goes, metrics in the ServiceMesh, most of the ServiceMesh, the main people, they already use, whether it's Prometheus and Grafana or some combination like that. They're already gathering up those metrics. You go through most of the time you go through a sidecar in a ServiceMesh Istio linker. You go through that keeps track of your metrics. It can pump it out to different places. You can map all that. Kiali, Istio has Kiali, I believe. K-I-A-L-I, that thing right there. That's tracking that kind of, that's showcasing that information. OpenShift, Red Hat OpenShift as well, shows that kind of stuff. So metrics in a ServiceMesh, more than likely, the ones that are out there, they come with this already. So they can track who's calling what, how long it takes, things of that nature. So in NATS, I thought, okay, what do we have in NATS? Well, I looked out there and I started asking some questions again in the Slack channel. Wally is the person that wrote, I believe, is the one that wrote the NATS exporter. So there's a NATS exporter that will run alongside NATS. I have all mine in whether it's in Kubernetes or it's in Docker Compose local. So it runs there. It hits the metrics endpoint in NATS, grabs the information up, puts it into the Prometheus format, gets scraped. They have a dashboard up on Grafana. So this actually shows the metrics of the NATS server. CPU, memory, number of messages and bytes in, messages and bytes out, connections, subscriptions, works great. One of the things I needed in my, again, for my open source app, the OpenRMF app, as well as in my my regular paid for job where I use NATS, is I needed to know those pieces of information down to a client level. So this, what's today, Thursday? This past weekend, in essence, almost a week ago, I worked on a per client metric. It's up in my GitHub, in my company GitHub. So I can actually have this piece of information, the bytes in, messages in, bytes out, messages out, subscriptions. I can have that kind of information on a per connection level, per client level. So I have 7, 8, 9 different clients that are connected in between my dedicated subscription or my request reply pieces. You can get this same information fairly easily down to the connection level. But there's metrics in both. Again, there's ways to do metrics in a regular ServiceMesh, and if you use NATS to implement the same functionality, it's there as well. Tracing, this is one I just recently ran into. So tracing, if you think of tracing, let me move my mouse. If you're thinking of tracing, it's usually you think of Jaeger, you think of Jaeger, the Jaeger application, open tracing, open telemetry, things of that nature. So tracing the ServiceMesh, again, most of them come with this already baked in. Istio and Envoy, you can export your tracing information. Linkerd has something as well. I believe Kuma from Kong, I've only messed with that a little bit. That has something as well. So tracing is, I'm calling API A is calling API B, which calls C, which may call D, or B calls D after something else. So what are all my APIs? What's my path? How long are things taking? That's what this answers here. So when I ran into this one, I kind of put out there in the Slack channel for the general channel, I said, hey, I wish that NATS actually had tracing. That would be great if I could know how long something took to get from here to over here and act on it, request reply, things of that nature. So Colin spoke up, I believe it was Colin, and said, hey, we actually have that. It isn't necessarily built in, like a Jaeger, inside of your API. You have to do a little bit of work, but we have a reference architecture. It's right here. We have a reference architecture to use for tracing. So I was intrigued a little bit. Pull down it's up there in their GitHub. The link is right here. You can go to GitHub, the NATS-IO GitHub. It's called NAT.go, NATS Open Tracing. The name threw me a little bit. That's why I never even looked at it, but NAT.go. So there's a reference architecture for you to set up your trace, set up your span of what you're calling. You take that and create a binary representation. You basically shove that on the front of your message data, which is already binary. You send that, and at the other end, you chop that piece off and use it, and then you go about your business with the rest of your data. So that works pretty well. I've actually used it with Go. I've also used it. I was working with Colin back and forth. Thank you, Colin. Picking his brain during this last week where he was already super busy, using C#.NET Core. So, and in the same idea, you have your trace, you have your span, you put that together with your message, you send it. I was actually doing that in C# and then sending it and then reading it with my Go subscription on the other end. I already had a simulation written in C#.NET Core. I needed to put this on too. So I would say one caveat is make sure when you're demoing this or you're running this in production or a live scenario that you don't do constant sampling like I did and lock your machine up. So be careful of that. But it worked. It works really, really well. The NAT.go application up there at GitHub will show you that. So both of them have tracing in their own ways, but both of them actually have tracing. So that was something else. You know, as I was comparing more and more ServiceMesh with some of the NATS things in the ecosystem, I was noticing a lot of similarities, and I was noticing, at least again for myself, what I needed. I didn't need to learn ServiceMesh with all the heavy pieces of it. I could get a lot done with what I already had in front of me. Honestly, it was pretty enlightening, to say the least. Very interesting. So, couple more things as far as that goes. Load balancing. I shouldn't have to explain load balancing to you, more than likely you know what it is. Former services, the replicas, the ServiceMesh can load balance between them. When I think of load balancing, I usually think of round robin. You know, every other one goes. You can do that. You can do locality based in a ServiceMesh. You can do weighted. It's very similar to what AWS does in its pieces. So you can do all that inside of a ServiceMesh. So, okay, so can you actually do that? Is that something you can do in NATS? Again, it was a question that I was reaching out to in the channel to learn more about it. So load balancing, in essence, you can read up more on queued subscriptions. Similar to me, again, this is my perspective. It's similar to round robin to me. One great thing I thought that was pretty awesome at that, to do queued subscriptions, you register your client with a queue name, and then you're done. It's pretty, again, going back to the title of this presentation, it's using the power and simplicity of NATS. I don't work for the company, but I preach this tool to a lot of people. Nice and simple, works every time, works fast. Register your client with a queue name. That's all you need, and then you go. You could also use this with gateways. There's the gateway piece in 2.0, the cluster, supercluster, the leaf node, where you can have geography, geo-aware subscriptions. So that kind of lends itself into some of the features. Let me back up. Some of the features here where you can actually go on locality. So there's a little bit of load balancing. There's similarities between both. Again, the subscribers that are closer get their information that way. So there's also, if you go to the about page on nats.io, there's a roadmap on a weighted load balancer. So even some of the things I was looking for, questions I was asking, even if they didn't do it now, they had something already designed in the future. So they're looking forward to that. Routing control, one of the last ones I'll talk about here before I finish up and give you guys back some time, is routing control. So with routing control, it's more of traffic shifting and mirroring. Mirroring or shadowing to perform functions. So traffic shifting is you're taking your traffic over here and slowly, migrating to something else. To me, I think of Canary when I think of that. But mirroring and shadowing, is there a way for me to mirror if I'm going to put some out in production? Is there a way for me to mirror and copy the request that kind of come through and then have them bring down here to me and just see if my newer code works the way it's supposed to, without impacting production, without screwing anybody up. Traffic shifting is basically migrating them from a version 1 to a version 2 slowly over time, things of that nature. I've done that in ServiceMesh, testing it, at least locally, by yeah, your YAML files that you apply. You know, it's YAML hungry. As far as looking at that again for NATS, the mirror shadowing, I've literally done the mirroring shadowing. I have done that with subscriptions, so I haven't done them with publications. But as far as NATS goes, I subscribe to the same thing, whether it's a wildcard, whether it's everything, whether it's the same exact subject, I guess I would say. But I want to see if there's a new piece of functionality. I want to see how my new service acts on that. I can actually deploy a newer version and then listen for the same subject. There's probably a little bit of hocus pocus wizardry you may have to do with publishing. You also have to make sure your permissions, your data storage, your accounts have to match, things of that nature. But there is a way to do it. I have literally done this to answer some questions for me. So there's probably a little more in routing control that you have more power, I guess you would say, with ServiceMesh, as far as like Istio, link and things of that nature. But you still have something with NATS. So again, it was very interesting to see all this stuff. So like I keep saying over and over and over again, inherently, you know, it's not called a service mesh, but inherently some of the features that you would think of, at least I think of, when I think of a service mesh, NATS has, or it can do for you if you just step out of yourself and think of it in a different way. It took me a little bit to wrap my head around it and start talking with some people. Again, I would stress you need to know if that you would even need a service mesh. If you're asking the question, hey, do I need a service mesh? I would say you probably don't. If you're saying, hey, how do I figure out circuit breaking, retries, timeouts, security between, if you're asking those kind of questions, you may want to look at comparing these two and see which one you can do, your team can do, you can support, and that can get you to where you need to be. And then test, you know, there's Istio, Link, and Kuma. There's several of them that can be here. One of the other things that I find, I'd say humorous, is that a lot of the people that are preaching Istio and Link and things of that nature for your service mesh, they're talking about how it can be used in Kubernetes, but it can also be used outside of Kubernetes. I'm still looking for a really good example of where that's done. Where with the NATS service mesh, I have used this exact setup here. I've used in Docker Compose. I have used in Kubernetes. I've used with separate services. I'm actually using this in a different application where I'm doing this in service mesh functionality, but it's not inside of Kubernetes. It's in on a couple of different servers. So you can use this kind of functionality, but it isn't just stuck in Kubernetes or just stuck in Docker. It's another big piece in weighing this back and forth. So a couple other things I want to throw at you. Now I can, like I said, I can sign off of this. Other things that NATS can do that you'd want to look at, it can do timeouts, retries. I was just talking to somebody in the .NET channel. Request reply as well as pub sub. And again, what I just said, you can create a service mesh without Kubernetes as the basis. You're not just stuck when using that. Circuit breaking, as far as the things that, you know, they think of service mesh that the major vendors pushing service mesh to do that I didn't see necessarily in NATS yet, would be circuit breaking. So you know, I haven't focused too hard on that. There's a couple blog articles I wrote back in September. I've gotten a little traction. I haven't extended those onto this. There's a couple other people here that can do that. One of the next people that's up, I believe, is I don't know how to say your last name, PDR, RIP. He has a blog series on some of this stuff. Kevin Hoffman has some very good things. Christian Posta has something started on getting started with service mesh that talked about piece by piece by piece. There's a lot of areas that you can research and then sit back and think of, what does NATS do for me? What do I need? Do I need a heavy lift of a service mesh, or can I already use, again, the power and simplicity of NATS? And if you're not quite sure, again, jump into your Slack channel. They are great at getting back to you and throwing out ideas. So that's really all I had. I give you back your conference. Thank you.
Dale, this is Derek. Thank you again for presenting, and thank you for participating in a way in the ecosystem to kind of push us, right, to kind of step up and actually meet some of the demands that solutions like you've been working on demand. I mean, NATS does both services, request reply, and it does streaming. And on the services side, you know, we've seen a lot of good ideas coming out of ServiceMesh. We just think that the constraint that it has to be built inside of a deployment platform like Kubernetes sometimes can be too restricting. But the ecosystem has given us great feedback. It's been a great relationship with everybody in the NATS ecosystem as we try to push the boundaries of what the technology can do. We get great feedback and recommendations and PRs and things like that from the ecosystem, and that's what makes it all work. So Dale, thank you for the time and presentation. I appreciate it.
You bet. Thank you.